Hey guys, we're on page 48 of your student journal, section 2.4, solving polynomials in factored form. The first activity here is a matching activity. An equation is considered to be in factored form when the product of the factors is equal to 0. Match each factored form of the equation with its equivalent standard form and non-standard form. So for instance, this is factored, but what would I do if I have, these two sitting next to each other? You would multiply. So whether you use the box or foil or table, then I definitely recommend the table. But whatever you do, you're supposed to multiply these to get the standard form. So I can multiply x by x to get x squared. All these have an x squared, so that doesn't really clue me into much. I have x times negative 3, which is negative 3x. I have negative 1 times x, which is negative 1x. After that, I do negative 1 and negative 3 multiply together to make positive 3, and that ends up being this one right here. And then the non-standard form, again, it's the same equation, it's just a different form. So what here looks similar, x squared minus 4x. If I subtract 3, that becomes 0, and if I subtract 3 over here, that becomes negative 3. So that's that. Here, x times x is x squared. X times negative 3 is negative 3x, and negative 2 times x is negative 5x. Negative 2 times negative 3 is positive 6, so that's over here. And this is very similar to the last one where you just subtract 6 to get the non-standard form, and so on and so forth. Yeah, that's it. So you just finish that up as you see fit. And then moving on to the next activity. We have writing a conjecture. Work with a partner, substitute 1, 2, 3, 4, 5, and 6 for x in each equation, and determine whether the equation is true. So we're just right in here. It's just we're going to plug in all these numbers, and you don't have to work it out on paper, but I will for the first one just to show you what it's asking you to do. So the first thing I'm going to do is I'm going to substitute 1 into this equation right here. 1 minus 1, 1 minus 2 equals 0. 1 minus 1 is 0. 1 minus 2 is negative 1. And 0 times negative 1 is 0. So that's a yes. Okay. I'll do another one. 2 minus 1 is 1. And 2 minus 2 is 0. And 1 times 0 is 0. 3 minus 1 is 2. 3 minus 2 is 1. 2 times 1 is 2. That's not 0. And so doing that, you actually get this. 2 minus 2 is 0. 2 minus 3 is negative 1. But 0 times negative 1 is yes, that works. Sorry, I skipped over 1 entirely. 1 minus 2 is negative 1. 1 minus 3 is negative 2. So negative 2 times negative 1 is positive 2, so that does not work. 3 works. 3 minus 2 is 1. 3 minus 3 is 0. 1 times 0 works, is 0. And now, without working them all out verbally, I will just proceed to fill these in. 3 minus 3 is 0. 0 times negative 1 is 0. 4 times 3 is 1. 4 minus 4 is 0. 1 times 0 is 0. And if you go ahead and fill all this in, it just goes in a diagonal pattern. So these are all yes, these are all yes, and then at the very last one, x equals 1. That works as well because 1 minus 1 is 0. And it says write a conjecture describing what you discovered. And so the point should be that anything subtracted by itself, so we have 1 and 2 in here, we have 1 and 2 in here, that works. 2 and 3, that works. 3 and 4, that works. So anything subtracted by itself is 0, and 0 multiplied by anything is 0. So as long as one of these numbers can be a 0, that's a yes. I'm going to go ahead and move on to this next page to give you an example. So the zero product property is that if the product of two real numbers is 0, then at least one of the numbers is 0. So let's say here x times x plus 6 equals 0. I have two things being multiplied here. I have x, that is one thing, being multiplied by x plus 6. And so if we know the product is 0, we know one of them has to equal 0. And the question is, does it matter which one is equal to 0? And the answer is no. Either of them could be equal 0. So you'd say x equals 0. That's this guy right here. And then we have x plus 6. Oops, I should have drawn it like that. X plus 6 equals 0. This is already solved. X is by itself. Here, it is not. How do we do that? Subtract 6, x equals negative 6. Voila, you have your one answer, you have your two answers, and let's check the answers. 0 times 0 plus 6. I'm just taking this original equation and substituting these values. So I have 0 times 6 equals 0, check mark, that works. Then I have negative 6 times negative 6 plus 6 equals 0. Negative 6 times 0 equals 0, check mark, that works. All right. As for another example, we could say, let's see, x minus 8 times 3x plus 12 equals 0. And again, you might ask, if the product after you multiply is going to be 0, one of these has to be 0. Which one? It could be either. So I say x minus 8 equals 0, 3x plus 12 equals 0, and then you go ahead and work that out. Solve for x. Number 1 is literally like the example I just did, or the first example I did, where it was x times x plus 6. So you're going to have two answers. You're going to have two answers here. You're going to have two answers here. You just write 5p equals 0, p minus 2 equals 0, and then you solve. And then all of these are the same. You say c minus 2 equals 0, c plus 1 equals 0. Number 7, some of you are like, oh, what does this mean? If I say x minus 3 squared, and squaring is multiplying by itself, really that just means this. And since you're going to get the same answer no matter how many times you solve it, you could just, you don't have to do it twice. There's no point. And then once you get to number 11 and 12, be very careful. You'll have three answers. This is one of them. This is another one. This is a third one. Right? Three different things that could equal 0 because only one of them has to equal 0 because 0 times anything is 0. Number 12, you'll also have three answers. These are those that you'll work out. Moving on into page 52, factoring. Okay, this one's a little tougher, but it helps us to solve. So you have to do 13 through 18 before you can do 19 through 20. So 6x squared and 3x, what common factor do they share? Well, 6 and 3 have a 3, and x squared and x have an x in common. So you could say 3x times, so 3x times what gives us 6x squared? Or 3 times what gives us 6? You would say 2. And x times what gives you x squared? So 3x times 2x is 6x squared. And 3x times what gives you 3x? And the answer here is 1. Right, that's factoring. So what would that look like in number 19? Rather, let's say 19 and 23. So for 19, you could factor out a k from each of them. You could have 6k plus 1. K times 6k is 6k squared. K times 1 is k. Right? And then you say k equals 0, and 6k plus 1 equals 0. You work it out. So you have two answers, k equals 0 and k equals negative 1/6. Oh wait, zoom, there we go. Next, the last one I'm going to do is 22s equals 11s squared. So before we can factor it, it has to equal 0. So it's, we could subtract 11s squared or we could subtract 22s. It doesn't matter. I'm actually just going to go ahead and subtract 11s squared. So you have negative 11s squared plus 22s equals 0. And then I could say you could factor an 11s from each of these. So 11s times negative s plus 2 equals 0. 11s equals 0. Negative s plus 2 equals 0, and then you solve it. So you divide by 11, s equals 0, you subtract 2, negative s equals negative 2, then you divide by negative 1, s equals 2. Number 25 really is just the height, y in feet above the ground of the ball is modeled by the equation y equals negative 16x squared plus 80x. Find the roots of the equation when y equals 0. Explain what the roots mean. So we will say 0 equals negative 16x squared plus 80x. So x is the time in seconds since the ball was kicked. So if you work this out, after you factor it, you will find solutions. You will find numbers that x is equal to. And since x represents time, then they represent a number or unit of seconds. And if the root is 0 and the height, y is modeling height. If the height of something is 0, think about your own height, however tall you are, 5 something, right? That means you are 5 feet, whatever, above the ground. Well, if you have a height of 0, where is that compared to the ground? That is on the ground. So after you find x, that's the number of seconds that it takes for the ball to be on the ground. And that'll do it for today. If you have any questions, make sure you let me know. Otherwise, good luck in your journal, in your textbook, in your quiz.